All right, so I had some time today on my lunch break. Wanted to make a video about Kubeflow, orchestration, the machine learning development lifecycle. Wanted to make it yesterday, but had a day with my partner and my baby. We went out and had a good time, so I didn't have time. But what I want to talk about is what is a machine learning development lifecycle. I think people that are in the industry know for sure about software development lifecycle. It's the same thing applied to machine learning projects. And this diagram shows it's a loop, so you iterate over this loop over and over to build your project, to improve your project, and to get it into production where it can provide value for customers. So according to this DataCamp article, there's 6 main steps, which makes sense to me. You have planning. You have to figure out, what is a problem that we can solve with machine learning. What kind of machine learning would we apply to that problem? And then you have to, because machine learning systems are data and the learning algorithm, they're tightly coupled. You have to prepare your data and understand your data before you really start tinkering with uh, the model algorithm itself and defining it and updating it. So the first step is planning. The second is data preparation. You got to know, I don't know if you can see this, let me zoom in. You got to know about your data. And then from that learning, you can start to build uh, your model architecture or your training pipeline. And then you need a way to evaluate those training runs, evaluate your data set versions, evaluate your model um, accuracy compared to others, like when you tune hyperparameters, um, and then you need to deploy that based on the evaluation, right? And once it's deployed, you need to continuously monitor it and maintain it, which would be another a maintenance step would be running the loop again, right? Evaluate the model, determine if it needs better or more recent data, fine tune the model, um, evaluate it before you deploy it, then deploy it, and then continue the loop. And so one way to do that in Google to automate this is something called Kubeflow. So Kubeflow is built on top of Kubernetes, which is like a super successful um, open source cloud native project for managing workloads and making them scalable and all sorts of stuff. It goes super deep. Won't get into Kubernetes because I don't honestly know a whole lot about it. But what's great about Kubeflow is that it abstracts away. Well, it can. So with Kubeflow, you can stand up your own Kubernetes cluster and then run Kubeflow on top of that. But what's great about Google Cloud and other cloud providers is they have managed versions of both Kubernetes and then managed versions of Kubeflow. And so Kubeflow can be run on top of VertexAI pipelines, which underneath the hood is Kubernetes. Um, so we use these Kubeflow APIs, and with them we can define uh, aspects of this life cycle, right? Some of this planning obviously wouldn't be automated, but you can automate some of your data preparation, model engineering, evaluation, and certainly deployment um, with a Kubeflow pipeline. And that's what I've done in my project. So if we take a look at the Vertex AI pipelines user interface, we can see an example of something called a DAG, which is just a fancy term to define you know, a list of steps that have to go in a certain order. So here we see I have something called a data flow template, a data flow flex template job. This is a component in my pipeline. And what it does is it runs a data flow flex template. So it defines, we won't have time to get into data flow flex templates in this video, but in another, but it defines essentially a data flow job, which is a Google Cloud managed version of Apache Beam, which is a distributed data processing tool framework or Python SDK. So I'm interacting, I define my data flow job in with Python code. So what's essentially happening is I'm taking records, images, raw JPEG images, and the labels associated with those images. In this case, if you've watched any other videos, it's dog images. I'm building a computer vision model that fine tunes itself to be better at predicting breeds, dog breeds, based on images. So this data flow job collects a specified number of images from my GCS, my data repository of dog images, and then processes them into a binary format called TF records because my model architecture and pipeline is built on top of TensorFlow. Processing data into TensorFlow records, TF records, makes the next step or one of the following steps, which is the training job, much more efficient because it just reads in those TF records and it's able to train the model, fine tune the model. So yeah, so this job has to run, it kicks off a data flow job. One tricky part with this with that I ran into with Kubeflow is that the data flow job, it's a distributed data processing framework. So it needs to kind of spin up, get started. It takes a while, at least with my configuration. And then it needs to process the images. I'm usually processing anywhere from 1,000 to 6,000 or 7,000 images at a time. And that step takes sometimes 10 to 15 minutes to run to completion. But in Kubeflow, whenever this component returns, it's essentially a function. So I'll show you that function. So this is the task. It just uses this data flow flex template job op, which is a component you can define based off the Kubeflow SDK, and then I give it a I give it a template file that it reads in that defines the parameters, and I have a max files where I can inject into the job that tells it how many images I want to process in a given run. And so that will, whenever that job has been, the data flow job starts, this component will return a green check and say it's done. And then I had to add this second part here because what was happening is the data flow job would run and then it would kick off the next thing, which would be the training job. But the training job really needs to wait till the data flow has processed all the images and output them to the GCS bucket where the custom training job pulls them. And so we had to implement a custom component that simply polls the data flow job and checks when it's done, right? So this is a lot of code, but essentially just takes a polling interval, and every 30 seconds it gets the status of that job, and whenever the job status reaches job state done, this component returns. And then my next component, which is my training job, will be able to kick off, and I'll know that the data has been processed and it's waiting for the custom training job here to pick it up and do the training. And so this training job runs as a VertexAI training job. It's defined as a custom training job op component. We can define an image for a Docker image, right? Because this runs in Kubeflow, so it's just containers running, weren't running workloads. So we have, I highly recommend using pre-built containers for stuff like this. Trying to build my own container was a big mess and I ran into a ton of errors, but I'm sure it's possible. But this is easy, so that they have a pre-built TensorFlow 2.17 container, uses Python 3.10, and instead of building my container and packaging in my Python code locally, pushing that to a container or artifact registry, and then reading that into my pipeline, my training pipeline, what I've done is I'm just using a pre-built image. I'm packaging my Python code as a distribution and pushing that to GCS. And then here I just reference my package in the custom training job component. And so I just pull in the Python code that I want to run inside this container and it runs. And that was, after many trials and errors, this most straightforward way to do this. And then finally, once a new version of a model has been trained, it needs to be deployed. And then here I have this deploy Cloud Run service, which just uses gcloud to deploy the new service with the new image. Right, and so this is the specification of my pipeline, right? This doesn't actually do anything except compile the specification to a JSON file. And then I push that to GCS. And so once this pipeline has been compiled, defined, compiled, and pushed to GCS, I can do my find my trigger, which would be a cloud function. So once this pipeline is defined, then I want to trigger or initiate a run of this pipeline, right? And so to do that, I have to call the pipeline job.submit. So I define this job, which is refers to the JSON spec I compiled from the Kubeflow pipeline code. I give it a path to that JSON file, and then I can inject parameters that I want to define that need to be more dynamic. And so I have, in this case, a model version, the new model version, the previous model version, which Cloud Run service to update, the number of files I want to process for my data processing job, and then whether or not I want to use caching. Caching is really helpful if you're debugging and you want to debug certain steps, later steps, without having to rerun other steps, because some of these things can take a while. This whole pipeline usually was taking around 40 to 50 minutes to run. Yeah, and so I mentioned in the previous video I'm using the champion challenger pattern, and so I review the metrics that are being output from my inference services being output to BigQuery. I review those metrics to determine, is the current champion version still outperforming the most recent challenger? If it is, the champion stays the same. If it isn't, if the challenger version, the most latest fine-tuned model, has better accuracy, that model gets promoted to my champion Cloud Run service, and then a new model gets trained and pushed and deployed with the challenger Cloud Run service. So I have two competing services running in Cloud Run. And so, yep, and so that's what this does. It's going to run the pipeline and inject into the pipeline certain parameters based on who my champion is for this given run. And this is what it looks like in the pipeline's UI. It's a DAG. You can click in on it and look at each step. You can review logs, which will be really helpful when you get errors to see what's causing your errors. So yeah, so that's orchestration of machine learning systems. Why we do it. We want to automate things and standardize things as much as possible, because machine learning systems are even more complex, you could say, than a regular software development lifecycle, because of both the data that you need to curate, version, monitor, and the actual application, which runs your inference and submits prediction requests to your model. So it's very important to have everything standardized and automated. And so And if you do it well, you can have your model and your service get better and better over time based on new data that's coming in and automatically being trained in your pipeline via some orchestration. And Kubeflow is how we do that. So thanks and have a good day.